Okay. Well, it's straight up on the hour. We're already being recorded, so maybe we'll go ahead and get started. We are on a fairly tight schedule, so I want to make sure that we have time for all our speakers to have their time to talk and answer questions. My name is Don Nelson. I'm an anthropologist at the University of Georgia in the United States. This is a session that is convened by 3 different people. So Henning, I don't know if you want to introduce yourself quickly.
Yeah, my name is Henning Rust, Freie Universität Berlin. That's probably sufficient, right?
Okay.
Okay, pass on to Tobias.
I can jump in. My name is Tobias Geiger. I'm working for the German Weather Service, located right now also in Offenbach in the hotel room.
All right, thank you. And thank you for everybody that is here and already participating. We have people from all over the place letting us know where you are, letting us know what the weather is. So we are about 20 degrees right now here in Athens, Georgia, and we got a storm front coming in. So we'll see what it looks like here in a little while. What I'd like to do briefly is just go over kind of the way that this will run. The meeting will run today, and then we'll go ahead and get started with the talks. It's broken, the evening or morning is broken into 4 different parts. We have an invited speaker at the very beginning, and this will be followed by our first session of 4 speakers. We'll have a brief break following that, and then a second session with an additional 4 speakers. Following that, we will have a lightning poster presentation and then invite people to go into Gather Town to talk with the poster presenters and to get a lot more information about what they're doing and just learn from them. So we will put those links into Gather Town just to make sure everybody has those as we're getting closer and closer to the poster session. So a couple of things that I would ask. The first is that we remain muted during the meeting, just for facilitating the presentations. If you have comments or questions, I ask that you drop them into the chat box, and I will be able to read those and ask those of the speakers. So each of the speakers will have an opportunity to present, and then there will be a time for questions and answers following that. And if you put your comment or question into the chat, either myself or Henning, whoever is running that session, will be able to ask those of the speakers. So we will work hard, as I think I already mentioned, to stay on time today. I know that because of the crazy hours, we want to respect people that are here. We are grateful that we are here. We don't want to abuse your goodwill. So we'll make sure that we stick to time. And for the speakers that are later on, they have a total of 15 minutes. That'll be, ideally, it's about 12 minutes of talking and about 3 minutes of answering questions. But the 15 minutes will be sort of a hard end so that we're able to respect the time of everybody else. The other thing I did want to mention before we get started is that I just put in a link here. If you want to click on this, this is a place where we can drop questions and comments throughout all of the conference, and so that the conference conveners and others can look back and use this as a way to help understand some of the key messages and where some of the key areas of interest are following the conference. So feel free to log on or to click on that link, take a look at it. If you have questions, comments that are not directly related to the speaker, please feel free to drop them in there. So what I'll do now then is I will go ahead and introduce our invited speaker. She will have 30 minutes to present and answer questions. This is Sally Potter. She is a senior social scientist at GNS Science. And Sally, if you want to go ahead and upload as I give a brief bio or share your screen, we can go ahead and do that. She, as I mentioned, a senior social scientist at GNS Science in New Zealand. She conducts research on the effectiveness of warnings and forecasts across all hazards, including impact-based warnings, risk perceptions, and behavioral responses. She applies results to improve communication products and science advice. Sally's co-chair of the WWRP High Impact Weather Project. Okay, Sally, it's all yours.
Thank you very much. Can you see my screen okay?
Yes.
Perfect. Okay, well, thank you so much for this invitation to give this talk. So as said, I'm a social scientist in New Zealand. So GNS Science is the sort of the equivalent of the geological surveys that you'd find in the US or the British Geological Survey, etc. But I conduct research also with New Zealand's Met Service. So I'm going to be talking today about one of the projects that we're doing under the WMO World Weather Research Program High Impact Weather Project on impact-based forecasts and warnings, and particularly that research end of it. So you'll see my long list of co-authors there. You'll see their names here as well. So we've got representation from a number of the different continents around the world there and the photo on the right. So I'd just really like to acknowledge their awesome contributions. And I think several of them are in this call today. So first of all, what are impact-based forecasts and warnings? Well, this is where, in case anyone's not familiar, instead of triggering your warning based on the level of phenomena or severity of hazard, you instead trigger on the base of what the impacts are likely to be. So in this figure, you can see this top row. I don't know if you can see my mouse or not, but the top row is phenomenon-based warnings. So a typical warning would be rainfall accumulations of 150 millimeters expected within 18 hours in typically a region tomorrow. So this takes into account the hazard and the hazard likelihood. If we add on vulnerability and to some extent exposure, then we get towards the impact-based warnings. So this is where you'd be triggering it on it might result in road closures due to flooding caused by the rainfall. If we get into higher resolution exposure, then we get more into an impact warning. So that's really focusing on that impact where the traffic might be delayed due to the road closures caused by the flooding from the heavy rainfall. And then if we take into account the behavior of people as well, we get the call to action warning. So this is where you actually trigger it based on the actions required. And that's a really difficult thing to do and require a lot of different agencies working together. So you can see that this really picks apart the equation of risk. So we've got the hazard, vulnerability, and exposure, and going into that risk equation. Now, there's a lot of documents and guidelines out there on impact-based forecasts and warnings from a practical and service level. So we've got these two guidelines here, and we've got the book that Brian led, Brian Golding, Towards the Perfect Weather Warning, which goes through that value chain and includes about impacts as well in there. We've got the multi-hazard early warning systems checklist that is also really useful for putting together a warning system. And we've got the Red Cross, Red Crescent and other agencies impact-based forecast and early action document there. So this is the practical end. We're going to be focusing more on that research base for how effective are they and where do we go from here. So how are they being implemented? Just a couple of examples from around the world here. On the left, we've got New Zealand's Met Service using impact-based warnings where we have these red warnings. These are triggered when significant impacts are expected to occur. It's a qualitative approach that they use. So if they can see a severe weather event coming, they might phone the regional council and say, what does this mean for your hydrology, your systems? Is there going to be flooding? You know, what else? What's the context at that time? And then the council or the emergency managers might recommend that it's actually a red warning rather than an orange warning. The UK Mett Office also uses this risk matrix type approach, same sort of coloured system to have basically shapes on a map to show when there's going to be more significant impacts. So that's from Andrea Taylor's 2019 paper, and it's also on the websites. However, there is a more quantitative risk approach we can take if we want to. Here's an example from New Zealand. During Cyclone Gabrielle, which was early last year, the weather data came from our National Institute of Water and Atmosphere. It came to GNS Science and they produced this landslide forecast, so a rainfall-induced landslide forecast. That then went into the risk model, which is called Riskscape, which you can Google and it's free, quantitative risk model. And we came out with this impact forecast. So this here is for the number of landslides expected to occur on the state highways. So you can see this Coromandel area. And then this is the number of expected houses or residential areas to be affected per ward. So Auckland City got a lot of impacts from this particular event. So this is another way to go about doing impact forecasts and impact-based warnings. However, we're yet to evaluate how effective this was and what use it actually was to the decision makers. So looking now at our impact-based forecast and warning group, we decided that with all this guidance out there, we wanted to know what next. Where are the gaps and the challenges that people are having with impact-based forecasts and warnings, so that we can understand what we should be researching next around the world. So in order to do this, first of all, we're going to do a literature review to find the gaps from there. We held 3 workshops, which I'll talk about a bit more. And then we're synthesizing that into an open access publication. If you want to know more about this project or the High Impact Weather program, then go to highweather.net. This map shows where the participants came from for the workshops, or the red countries. So looking at the literature review gap analysis, we searched the internet, found a load of documents, and we've been synthesizing them to understand from an academic and research point of view where the gaps are, looking at the hydromet services, practitioner documents, reports, and also from the user and decision-making perspectives, what they think the gaps and challenges are. We then held a workshop series. So we had over 350 people register from around the world, from a wide range of different disciplines. So the aim of this was really to bring people together, anyone who was interested or had experience or just wanted to share their thoughts and challenges, to try and identify those gaps and challenges. So the 3 workshops were held in late 2022. The first one had a focus on underpinning data and model integration. The second was on people-centered impact-based warnings, and the third focused on the multi-hazard aspects. The times were staggered to try and, so you could at least basically get to 2 wherever you were in the world, and then they were all recorded as well. And they used a virtual whiteboard on Mural, so people could come into this at any time of the day or night to contribute as well. The general structure was that we had an introduction presentation from invited speakers about the topic that they were experts in, and then we had this interactive whiteboard. So we looked, first of all, where people were from, the gaps and challenges. So this is the example from the underpinning data and model integration session. What did they think were the gaps? What were some of the solutions that they had found or could be potentially solutions? And then what does success mean to them? So we did that for the 3 workshops, but with those different focuses. In terms of analysis, then a subgroup of our working group looked at all those data. So we got those post-it notes and we put them into Excel spreadsheets, and then we coded the data and identified the themes. So we did this in a number of rounds between us to ensure consistency. And then once we had these themes that you can see in the yellow there, we would write the summary, the description of what all those post-it notes were saying about it. And then in April last year, the working group got together in Exeter at the UK Mett Office to discuss those findings and relate those to what our prior experience and knowledge is, our knowledge of the literature review, and try to identify then what some of those outstanding gaps are. We're at the process now of synthesizing that into the publication. So I'm going to share the preliminary findings with you now. But yeah, please do note that this hasn't been peer reviewed yet or published. So in terms of the literature review results, we synthesize this down to how it relates to the expert researchers, the practitioners, and the decision makers and users. So if the bar goes all the way across all 3, it relates to all 3. If it's just on 2, it's just for those, etc. So some of the findings were the gap is that we need to explore the value, objectives, and interpretations of impact-based warnings, determine the governance and co-production techniques, try and understand what the different roles are for the public sector, the private sector, and anyone else like media, etc., who are getting those warnings and passing them on. We need to explore the measures and relationships along the warning chain or value chain, and what support they need in order to be able to do that and to work together, and what data they need. We need to explore how we can possibly standardize and automate the techniques, particularly for data sharing, how we can translate research to practice, and also analyze people's experiences with using the impact-based warnings, whether they're like an emergency management decision maker or the public. So our general challenge for this project is to understand, did our workshop participants agree with these challenges? Do they disagree? Were there any more challenges? And the key thing, I think, is trying to find the solution. So did anyone have solutions to those challenges? And then of the remaining gaps that we still need solutions for, what can we do? What research can we do to try and help fill those gaps? So that's the overall aim, and we're still trying to work with that as we go through the publication. So in terms of some of the challenges and responsibilities according to theme. So the first theme there is roles and responsibilities. So the challenge there is that who has the legal authority to warn? And I think this is a pretty well-known challenge for impact-based warnings, because meteorological services often have that mandate to have the hazard information, but they don't have the impact information. They often think that that lies in the realm of emergency management. And so connecting that information becomes the key. So some of the solutions there that, may or may not relate to that exact challenge is that co-location of the different agencies can help with information sharing there and having a really clear understanding of the roles and responsibilities, and developing those agreements. So having it clear in the legislation, who's responsible for what and how they can co-produce these warnings. In terms of cost and feasibility, one of the challenges there, especially in the countries with less money, essentially, is how can they afford to have such a system, develop their expertise, for example, in getting the impact information or having quantitative risk models or anything like that, and have those communication platforms to try and support impact-based forecasts and warnings. So some of the solutions there are try and collaborate. So, for example, you might be able to have a regional, multi-country, globally significant body that can try and combine all those resources and share it between them. In terms of interoperability, one of the challenges there is that data sharing and standardization, and that's really being picked up in the literature quite a lot as well. So having a common set of standards can be very helpful, for example, to try and make sure when data is collected, it's done in a common way and is interoperable. In terms of input data, one of the challenges there is perceived to be the amount of data that's available. So a lot of people say, well, the impact data is just not out there, or how can we go and get that data? And my PhD student at the time, Sarah Harrison, has about 4 or 5 publications on this, and she found that at least in New Zealand, there's actually a lot of data out there. It's just held in a lot of different agencies. So it's really all about the sharing of that data that becomes the challenge, and knowing where it is. So one of the things you could do then is conduct that stock take of existing impact databases, find out where it is in your country and who's got it and how you can get it and are you allowed to get it, basically. We can do more collecting of impact data, post-event surveys, etc., so that you can try and collect that data and get the appropriate inputs for the impact-based forecasts and warnings. And part of that could be having those interview protocols ready. So it's also not just about building damage, but it's also about how what the impacts have been to people, society, disruption, etc., but done in an ethically responsible way. You can also have a look more at the value of dynamic vulnerability and exposure data. So that's something that we're just starting to work on now to really understand. Doesn't matter if it's day or night, weekend, weekday, how much does it matter what commuting practices are like on the resulting warning? So I think this is a cool piece of research to understand really how much detail do we need? How high resolution is it actually effective when it comes to decision making and behavioural response by the public? And then one of the other solutions identified in the workshops was training the different agencies on the risk concepts and the elements of risk as well, to ensure everyone's got that common understanding. The next slot is on multi-hazard complexity. So when I'm talking multi-hazard, this really is not just wind, rain, hail, you know, I'm talking weather, volcano, earthquake, tsunami, etc. Okay, so this is how can we produce an impact-based forecasting or warning system that goes across all those different hazards. So this is very complex and difficult, particularly because it's often across multiple agencies, such as in New Zealand. So this is a factor of trying to manage those collaborations, all their different processes and funding operation models, communication practices, the platforms that they use, and it's also a challenge in terms of verification for those, especially impact warnings. So some of the solutions there again comes back to agency coordination, particularly for setting those activation thresholds. If you really are having a multi-hazard warning system that uses a common warning structure, for example, you know, yellow, green, yellow, red type warnings, can you get those thresholds to warn consistent across the hazards? It'll be a challenge. And the effective actions there, that's a huge one as well. So if you're telling someone to go into a ditch because of a tornado coming, but there's also flash floodings, you know, get out of the ditches. So how do you try and manage those potentially conflicting actions that you're asking people to take? In terms of scale and resolution of impact-based forecasts and warnings, one of the key challenges that I have found is that when you have a true impact-based warning going from like a storm going across both a city and a rural area, if you're taking a true approach, then the city would always have a higher level of warning because there's higher exposure of people in that area compared to the rural area. So that's looking at societal risk, where your key audience is emergency management, basically, because they're making those decisions. However, if we're having a truly people-centered approach and empowering individual decision-making, which in my view, I think is quite critical, then the people in the rural areas should also receive a high level of warning if they have a severe storm coming their way, because they deserve to know that they're going to be impacted, even though it's only one of them potentially. So this is a really big challenge and potentially, in my opinion, a fatal flaw for impact-based warnings. So it's a huge challenge and one that I think we need to address. So one of the potential solutions that was suggested in our workshop is that each area, so for example, just a city is used. So that's the select localized areas. And everything, all the warnings that are produced are in relative terms for that city or for that rural area. So in terms of tailoring then, how do we personalize information? So how do we really get the impact information to a person on the ground that is going to be meaningful for them? Because we know from social science research that having guidance information that's meaningful and easy to do for them is crucial. So how can we try and do that? I've got a TED talk on how we might be able to do that using big data. However, I think a better approach would be using user-led personalization. So potentially the person can go into an app and determine what their threshold for warning is and what is meaningful for them, whether they're a farmer and they want agriculture information, or they're particularly interested in the electricity outages, for example. Can you have a way that they can determine what their thresholds are to help that personalization? In terms of communication, some of the challenges there, how to communicate about high impact, low probability events, especially in terms of the risk matrix, and risk communication, uncertainties, likelihoods, etc. So there is quite a lot of research out there on how to communicate risk and these sort of events, but we could be doing a little bit more research on relative risk. So for that particular city or for a person, how does this compare to before and after, etc. And other solutions there are using multiple channels to try and make sure there's a lot of exposure to that warning. In terms of uncertainty, again, communicating uncertainties is always a challenge. Again, there's a lot of research and literature on this, but a lot of mixed findings as well. So be good to do some more research on that. But some solutions there is try and at least have consistent warnings, acknowledge uncertainty, and all basically singing off the same song sheet. Verification is a challenge for impact-based warnings, because if you tell a community to evacuate because of a giant storm coming, they evacuate, the impacts are not as high as they otherwise would have been because people evacuated. So how do you possibly verify such an event? Also, there's just not that much impact data out there post-event. So we could work on trying to understand how we can collect that kind of impact data in a meaningful way, but also focus on things like the actions that were taken could be your verification standard. So that's the uptake of those warnings and the mitigation of the losses. We could also be doing more evaluation, like collecting data from the users after the event to say, how valuable did you find this warning? What did you do with it? In terms of knowledge translation, there's a lack of platforms to share experiences about how they have used these kind of warning systems, what's worked and what's not. So I like to think that these workshops that we run is a first step in that direction to share those experiences, but I think we could be doing a lot more there. And actually the value chain project, which you can look up on the highweather.net website, is also one way that we can collect data on the ways that warnings have been given through the whole value chain, and that could be a platform to try and share those experiences as well. And some of the solutions there, developing risk and uncertainty training along that value chain. And if it's appropriate for your country and from the opinion of the Indigenous peoples, then you could be learning from Indigenous knowledge as well. So that's the end of my presentation. I'll gladly take any questions. Thanks very much.
Great. Thank you very much, Sally. I appreciate that. So we do have a few minutes left. If people want to just go ahead and type a question into the chat for Sally, where she can either read it or I can read it to her, that would be great.
Just would like to say great effort, Sally. Really appreciate.
Thank you.
So I guess I do have one question, Sally, for you. You talked here at the end, about knowledge exchange platforms and things like that. I'm curious, I don't know if you talked to people after the workshops about what they learned just from being in workshops, and whether, different kinds of, relationships were made, or if they learned a lot just from listening to other people there, because it seems like you brought a lot of varied people together with a lot of varied experience. And so we see what you and your team take out of this, but I'm curious if you have an idea of what the participants took out of it as well.
Yeah, that's a good question. We did do an evaluation afterwards, and we got some nice feedback to say it was really great and they loved it and they want more of that kind of thing. So it's a matter of trying to find that. I mean, this conference is a great example of that. It's free, it's virtual, and it's accessible to anybody who has enough bandwidth to be able to attend. So I think any kind of forum like this is a great opportunity to be able to share those experiences.
Okay. So we do have a few questions in here. So let me go ahead and see if I'll put them in the order that they came up. So Faye Wyatt would like to know, what is the #1 challenge that you would like to see addressed?
Thanks, Faye. And she was part of our work. For me, I think it would be the societal risk versus individual risk question. I'm starting to be able to progress that in my brain a little bit. I would like to see us, at least in a New Zealand context, to have individual risk recognised. So this is that the rural person gets to have a warning as well as, like a high level of warning, as well as the city person. So it's finding a way for that to work, acknowledging the impacts, but perhaps not necessarily taking that true risk approach. This throws into question the use of risk models to some degree, or I think just the whole questions the whole way we do it, really. So then another question is it worthwhile spending a lot of money developing a risk model to support this kind of approach, or is a qualitative approach enough when it really comes to decision making on the ground? So
we have another question here from Julia Charlotte Koch that says, Thanks for all the insights. I wondered why you put such emphasis on the challenges related to spatial resolution.
Yeah, okay. I think it's to work towards that personalized warnings approach. So how, like if you have a warning that's relevant for a nearby mountain range and for the city, then it starts to become quite meaningless and you start bordering on warning fatigue if that city keeps getting the warnings for the nearby mountain range. So in terms of resolution, that I think is super important. But really it feeds then into that societal and individual risk kind of challenge where your resolution there is related more to exposure, I would say, than the spatial resolution of the hazard model, if that makes sense.
Okay. So Beth Ebert says, thanks for your talk, Sally. Are there some examples out there of effective individualized warnings? It's
a good question. There are, I think, in other fields. So less talking about weather warnings globally, you know, and thinking more about other hazards. Okay, so one example is earthquake early warnings, where somebody can get an alert on their phone of what the shaking intensity is like in their location. It's only hazard. It doesn't take into account the impacts there. However, you could argue that the level of shaking intensity is very strongly related to impacts, you know, if you happen to be in a building at the time. So kind of one example there. I think emergency mobile alerts sort of getting there too a little bit because it's getting about individual locations and can have those different elements of your message inside it with hazard and impact and guidance. You know, it brings it all together. It's, to be honest, El Salvador is getting there quite well. They've got a lot of aid money coming in, and the National Weather Service helped them to set up an impact-based warning system in their country, which they've gone on to make multi-hazard, and it is truly inspiring. And I'm learning a lot from it and starting to adapt that to New Zealand. I think the Australian system is also sounds very promising with their multi-hazard approach. It's less, both of those, El Salvador and Australia, from what I can gather, are not so much personalized though. It's more that multi-hazard approach. So perhaps not there and a long way to go yet for everybody.
Okay. All right. So Linus, I see your hand is up. If you do have a question, if you want to type it into the chat box, that would be great. So we have also a question from Colleen Vogel that says, thanks, Sally. Really interesting. It says, oh my gosh, my messages just skipped where they go. I noticed on maps, few people attending workshops, relatively fewer from Africa. How can we enhance the African reach and work?
Yeah, thanks, Colleen. We actually had quite a few participants from Africa, but from a couple of countries within Africa. I don't know if that's a language thing or quite what's going on there. You know, there's a lot of factors involved. I mean, one potential way, as you know, Colleen, is going through WMO contacts already in those regional offices, and I think there's some progress there. Otherwise, I think our approach to having the workshops across different time zones tried to allow for that sort of accessibility, but perhaps infrastructure, you know, requirements to attend an online workshop is what's limiting there. I'm not sure. So, Colleen, I would always gladly take your advice on how to expand reach in Africa.
Okay, so Sally, we have about 1 more minute here, but Simon Ageet has a question that says, thanks, Sally. I agree with your verification of impacts is not trivial. Do you have any verification tools or methods for IVF or warnings?
Yeah, it's certainly one of the biggest challenges. And I know, for example, the UK Mett Office, I think, is working in this space quite a bit. Well, in the most simplest terms, scouring the media and potentially crowdsourced reports of impacts could help. Other ways that people are doing it is actually just basing it still off the hazards, like the strength of the wind, for example, basing it on people's decisions. So having post-event surveys that ask stakeholders, but potentially also the public, what actions they took. Because at the end of the day, that's what a successful warning is, right? It's what actions people are actually taking, and did they feel empowered and informed to make their decisions and keep themselves safe. So I think if we can capture that better, then I think we'll be on the right track.
Okay, great. Well, Sally, we have filled up the 30 minutes. Thank you very much for the talk and for your responses to the questions. There are a few questions in the chat box that we did not have time to get to. If you have a chance, maybe you can just respond briefly to some of those, give some feedback to people. That would be wonderful. So we are going to move into the first or the second section of the session. And Henning, I believe that you're chairing this. Is that correct?
Yeah, I'm taking
All
over.
yours.
Thanks, Don. Thanks. So I chair the next block with 4 talks, starting with Tobias Geiger from the German Meteorological Service on how to provide actionable information on weather and climate impacts, a summary of strategic, methodological, and technical perspective. Tobias, can you share your screen? Our speakers have 15 minutes in total, so maybe it would be good to keep your talk a little bit shorter so we have a few minutes for questions afterwards. Everyone who's not speaking, please mute your microphone. And yeah, I see your screen, Tobias. Then the floor is yours.
Perfect.
Go ahead.
Thank you, Henning. Thank you all for listening and attending. And thank you, Sally, for giving this great presentation and as a starter. So I'm actually following up on Sally's path here. We are a group of, or we have a working group across different national meteorological services from Switzerland, Austria, and Germany. And we have been thinking of really how we can provide impact information as services to the public or to specific user groups. And what are the main challenges that we face in these 3 weather services, and from talking to other people, we see, and listening to Sally's talk, I see that there is very many similarities. So yeah, I want to provide here some insights from our work and really our experiences. And we actually already have a paper accepted on that. It's just the news came in a few days ago that it's accepted. It's not published yet, but so you can find it shortly online. It's also open access. So the question is how to provide actionable information on weather and climate impacts. And related to that, I would also pose the questions who to provide this actionable information and why to provide that information. And let me start with why, which is quite simple, and probably most of you will agree in this setting here that following the value chain, this graphic that we somehow adapted to our needs a little bit at the German Weather Service, that providing impact forecasts or impact information can lead to better decisions. So usually the societal decisions are taken based on the impact rather than the weather and pure climate information. So providing the impact forecast might lead to better decisions. And another aspect that we came across, which is probably not so communicated widely, is that you can actually, as a weather service, widen your user community, because there are some users that are not able to integrate these weather information into their decision making, but they might be as well more ready to integrate the risk information or impact information into their decision making. So that's for the why. Then the question is, who is to provide this information? And Sally argued, okay, national weather services might not have the mandate to do so in some respect, and that is also the case for partly for the German Weather Service. But we do want to argue, or we do argue in this paper, that actually national meteorological and hydrological services have the expertise in running complex models and providing operational services. So they're at least in cooperation with stakeholders, users, are a good starting point to provide those information. But as I say, really in cooperation with stakeholders, because you need also, as I will detail further, you will need this the expertise, you need the data, you need different you need these stakeholders, the users, the consultancies, and all the co-providers in actually designing this information and bringing this information out. So the Weather Service has some sort of responsibility in approaching these stakeholders in co-designing these services, and the stakeholders have to take ownership also in this respect in order to personalize this information to their needs and make it useful for them. And yeah, following Sally's talk, thinking about this topic, we basically came up with 3 major challenges that we face in our context here. The one is, I just mentioned, is what we call the co-design process, or the transdisciplinarity that we're facing here, the user engagement. So really how to get in contact with the users, how to design these services in cooperation with the users. The second issue is really how to run these impact assessments and risk assessments. What is the suitable model to do it, and of course the data availability on all the components of hazard, vulnerability, and exposure to run a risk assessment. And the last point is actually the communication of these risks, the uncertainty involved, and also then in the end the validation, evaluation of the forecast. I don't have time to focus on all these aspects in detail, but I want to go more to the second point, really on the impact models and how we think we can provide these services in a better way. So let me start with what we usually do today. So, or as we see it here, is that you have the risk propeller, but instead of taking the risk propeller as a full propeller, usually the hazard is provided by the weather services, and then someone is picking up this information. Some stakeholders, user groups are picking it up and trying to get a risk assessment or build a risk assessment based on that. And that is what we would in our paper call, there's no HEV mindset in place. So actually need this mindset in order to provide a full risk assessment. And the solution we provide here is really simple, looks really simple in this graphic, but I think it has some implications in reality, especially looking at our own work every day. So instead of looking at this risk propeller as a discrete propeller, we propose to look at it as a simple triangle, so at a risk plane or as a hazard, exposure, vulnerability, or short HEV plane. And by doing so, you basically, if you draw it, I just turned it around for visualization purposes. You have the same structure as for the propeller. So you have the hazard from one side entering, you have the exposure and vulnerability information entering from the other side. So you have the stakeholders, user groups down providing these exposure vulnerability information, and you have the weather service up providing weather, and also in our aspect also climate information, climate forecasts for more long-term impact and risk assessments. And the idea here is instead of having this gap that I tried to visualize earlier, you actually don't see this gap here, and it's more like a continuous space in which you work, in which you do your assessments. And if you view it like that, you actually live in an HEV mindset. And I will show you now that most weather services actually already live in this space without maybe even knowing or without really naming it like this. So usually, if we have here now 5 different points located in this plane, and the first one is what we call hazard only. So it's really what we are used to do as a weather service in providing hazard footprints, hazard intensities, etc. And the further you move down towards exposure and vulnerability, the more you come to the full risk assessment, which is located at point 5. But I want to say here, for example, what we call customized hazard is what is regularly provided by weather services as warnings. So it's warnings using fixed thresholds, but these thresholds are of course defined based on vulnerabilities that you're aware of in your society. And so you're already in this plane and working in this plane, and you are on the way to providing risk assessments here. The same holds true for what we call point 3. It's a hazard vulnerability focus. You do not include exposure information here, but you have information based from past experience, for example, on extreme events and their potential impacts. And based on that, you design the warnings. So each forecaster in his back of his head has this information, has this experience when designing the polygons, when designing the specific warnings. And the same is true, of course, for the hazard exposure focus. So when you actually know about infrastructure that is vulnerable or that is in place in your forecast region, you actually take this exposure into account, for example, exposed hospitals or whatever close to riverbanks. So this is already in the minds of the forecasters. And the last step, which is usually not so often taken, is actually the full risk focus, where I actually try to provide quantitative calculation using all the components, hazard, exposure, and vulnerability. But by looking at this graphic, we want to basically take the or like loosen this border, or reduce this border between these different steps. So it doesn't really require new things, new strategies, but it's rather you live in this space already as a weather service, and this might make it easier to acknowledge that. So in summary, one important thing is really that I think you have to live this HEV mindset. You have to acknowledge that using such a framework is not an add-on to your regular activities, but it really integrates what you have as current forecast and warnings into a larger picture. And once you have done that, you naturally interact with all the users and stakeholders, and that is then by design a transdisciplinary approach. So you actually have to interact, you have to provide, or you have to obtain data. And another aspect is that such a framework is seamless. So you don't really have, you do not have a model to provide the hazard, and you need an extra model for the impact assessment. But in reality, you can basically switch it off and switch it on as desired. From our perspective at DWD, it's really important that it's somewhat seamless on the weather and climate scale. So it doesn't really matter if you talk about whether you went next day, or you talk about a seasonal forecast for heat for the next summer in terms of risks. And of course, you can do it on a single grid point, you can do it on a whole country, so that there's no limitations in place. And we are actually doing this now and working with a model like that. And yeah, as I just mentioned, time is short, so there's many more aspects on strategic, methodological, and technical dimensions. We have some recommendations on how to start, first steps, and many examples in the paper. And yeah, I'm happy to share the link once I have it. Yeah, thank you very much.
Thank you, Tobias. Very inspiring, nice work. So we have, you're very well in time. We have a few minutes for question. This is so far only a comment from Beth. Nice work, Tobias and colleagues. Very elegant. So I see there is a question from Adrian Perels. As regard of inclusion of different types and detail levels of information, is the study also considering the effect of organization of information markets, in brackets, public, private, common pool, resource, club good, etc., and the economic consequences of sharing information of different partners?
So I'm not fully sure if I understand the question correctly, but let me try to answer it and see if it goes into the right direction.
Should I explain it briefly?
Yeah, maybe say
Sure.
a few words.
Good evening. We don't have much time, but so of course we're talking about warnings. So anyhow, we are talking. There's a strong emphasis here anyhow on public provision of the eventual warning services. But in a part of the cases, one could imagine that to have really excellent level of information provision, there would be also partners involved that have sensitive information, either in terms of privacy or whatever. It can also be commercially sensitive information, like if you think of insurances. And if you just share everything, that has all kinds of consequences. And there are all kinds of reasons why that is not totally happening. So to some extent, the perfect warning, to some extent, may enable better benefits in terms of what you prevent, but it may also cause cost. In the worst case, it's not possible anymore to provide an insurance. And that would cause cost as well. So that's the question.
Okay, yeah, thank you, Adrian. I get it now. I think that's the important part here, that so to some extent the framework should be provided by the weather services and also the setup of these risk models, for example, but not all the information in the end might be publicly available. So as you say, there's some exposure information that is protected and that is private, and so there's a big role of these, what in the paper we call it boundary organizations. So all partners that are somehow involved in this process, and then they can basically use that information or use the model also for themselves and run their assessments for themselves, instead of providing it all to the public. So it's some of the interplay. So there's some responsibility of the weather service to provide this information to the public, but then there's also a large portion of private actors that probably can also use that information to make money with that, and they might even better in providing specific risk assessments that are beyond the scope of National Weather Service's mandate.
Yeah, in the interest of time, I would suggest that we continue. There's one more question in the chat, and I think you can also pose more questions to Tobias, and maybe he can answer it during the next talks. So as the next speaker, we have Marcos Saucedo, analysis of meteorological thresholds and its association with impact data, methodological process in Argentina. Marcos, can you share your screen?
Yes, I'm just on that. Okay, so well, have a good afternoon, good evening, good morning to everyone. Well, I'm Marcos Saucedo. I will show some work we are doing here in Argentina, where we are part of a team. I'm part of a team from the National Weather Service. There is one person that is from the civil defense that is working as a team here. Well, just to begin with, in November 2020, we implemented a new early warning system in Argentina with different color levels. And in part of that, we also defined a series of thresholds based mostly on climatological data. As you can see here, this is Argentina. Well, it's a very large country with almost 3 million square kilometers. So for different regions of Argentina, based on climatology mostly, we have a very scarce impact data. We define a series of thresholds for example, rain and wind. Well, we use this is part of our decision tree, just to issue a warning. So our step now is just to move in the direction of impact-based warnings. So what we want to do here is just to try to relate the thresholds that we defined in 2020 with some impacts. So we begin as this early warning system started. We start also to just make a compilation of data of different impacts that were related with meteorology, and try to gather all this information and make, well, this is part of a project just to improve our forecast and warnings. and this is part of the project of as SMN. And also, well, this is also in the framework of a objective of the National Plan for Disaster Risk Reduction and Climate Change Adaptation and Mitigation. So this is part of our continuous improvement of our warning system. So just to begin with some places here, what we see are the regions that we just started to gather data. So here we have Buenos Aires. Well, not exactly Buenos Aires, is some part of the south of the city of Buenos Aires that is called the Sarandí Santo Domingo Basin, and also here at the city of Cordoba and its surroundings. Well, this is the Suquía Basin. Just try to gather some information from here that we have another project that is called Prevenir, that is for flash floodings that we are working with Japan. Also, we try to gather information from some places here at the Patagonia region, 4 cities or 4 regions specifically. Well, this region of Argentina is more known to be very windy during all time of the year, and during summer we also have some thunderstorms here that sometimes they generate great impacts. So just to begin with, we also have another project just to make some classification of different impacts in the following categories that we see here in this box and the downside of the screen, where we define the different categories from transport infrastructure damage, house damage, impacts on the population, damage to livelihoods, damage to vehicles, to trees and forests, urban infrastructure and impact of essential services, and also damage to agricultural and/or livestock activity. So, well, one of the big issues that we find here is that when we start to gather all the information, well, there were many people doing the same. We had to try to gather all the information together and try to use a unified database. So, well, the problem, or maybe the most the biggest issue that we found is that sometimes we know the impacts, but we are not really sure about the value of the events. For example, we may have a thunderstorm and we know what happened. We can see from the media, or some people just put it out on in X, for example, and on Facebook, but we are not sure about what was for example, the wind speed of that phenomena. So we had to make with a lot of work trying to complete the missing data, just to relate the meteorological data with the impact data, because well, as you know, Argentina is quite big. Maybe we don't have very much data. So sometimes, or many times, we have to use not the observation from the National Weather Service, but also from automatic station, maybe from people that have automatic stations. So we also have to make a study about the quality of the data and see, okay, this is reliable, or maybe we have to discard this information. So we have had a lot of work, and maybe it's maybe the most important issue that we had to face in this process. So, well, I will just show some preliminary results. We are just analyzing all this information. Well, you can see here, for example, the different reports that we have in the different places. This is from Buenos Aires. For example, this is related with rain events, rain and thunderstorm events in blue, and in orange we have cases of wind. Well, you can see, for example, in Cordoba, well, we have the most reports we have in the summer period, mostly. And then in here we have, for example, in Commodore Rivadavia, this box maybe is just during all time of the year, mostly during winter and part of the early spring. Here in Reservoir, for example, mostly we have all reports of rain. We also just analyze for example, the reports from different damage, for example, in transportation, livelihood, trees, and so on. For example, this is from Buenos Aires. And also where we can see here is the frequency of reports and the intensity of the wind. For example, this is on the right side. As we can see here, for example, the biggest bar, and see this maximum of reports. This coincides mostly with our yellow warning. So we know that there are some few events that sometimes we have some impacts. Even we should have maybe no warning at all, but maybe this is possible to have some impact here near Buenos Aires. Also, for example, this is for precipitation. You can see, okay, this some impacts here related. This is with transportation from rain events, and also with a lot with some like 15 millimeters in one day. We may have some problems here. This is for us in our early warning system. This is also a green snow warning in this case. Well, you can see this in other, for example, in other type of impacts. Here what we have is also, well, we just classify this regarding if the rain events is during one day on the left side, and what happens if we consider the precipitation during 1 hour only. We can see that, for example, the threshold, the values are even less than in one day. So maybe we have to consider also precipitation in 1 hour. The intensity of precipitation in 1 hour may have some impacts, even with very low values of rain. I mean, less than of the order of 5 to 10 millimeters in 1 hour. We may have some impacts here near in the Buenos Aires region. Well, this is also for Córdoba. Well, something very similar of what I showed before. Well, we just skip this and only to make it on time. But for example, here, this is what the same from Córdoba, and we can see some values of rain or almost 120 millimeters in one day. But if we use this, if we decide to see what happens if we take 1 hour of rain, we can see, for example, that the values of almost 50 millimeters or even less, well, we can see some impacts here, for example, in the transportation case. Well, this is for the rain from El Bolsón and Comodoro Rivadavia. This is this case on the right side is for wind events. Well, we have many cases. Here the wind is in kilometers per hour. We can see that, for example, from 70 kilometers per hour, when we shall start to have some impacts, and even we may see some large impacts here. In this case, so 130 kilometers. We are talking about red warnings cases. So, well, just to conclude, to sum up, I would say that, well, this is part of our strategic plan, seeking to improve our early warning system that we implemented in 2020. And this is one important component of our impact-based forecast and warning project. Of course, this process involves adapting the thresholds for issuing weather warnings, but taking into account the impacts produced by different weather events. We have applied this methodology only 6 places in Argentina. We have a really large road to go, because, well, we have many regions just to study and see what happens there. And well, as I mentioned before, the greatest difficulties is the collection of information and try to associate it with a reliable estimation of intensity. That means that we have many impacts events, but we don't have. It's very difficult to obtain a reliable meteorological value that you can just say, okay, we can associate this. So that results in in some cases, a very few cases, to analyze and get a better threshold estimation. So that's it. Thank you very much.
Thank you, Marcos. Perfect timing. You can type questions for Marcos in the chat. There's already one from Beth Abbott. Nice talk, Marcos. Is there a way that the public can provide impact information directly to SMN, e.g. via an online portal or smartphone app?
Well, some years ago, we have just an initiative of that type, but then we couldn't get, we didn't have many success in that. But well, now it's one of our plans just to enhance the people just make reports. We usually seek for reports in X, for example, or Facebook or whatever, but it's some part of our initiative. But yes, we need more interaction. I mean, at least we need interaction with the people just to report to SMN. We have some initiatives, but it's not very big at this time.
Okay, there's another question from Brian Mills. Thanks, Marcos, for the great talk. How often do you think the impact data and thresholds will need to be updated as people adapt and respond?
Well, I think this will be very large time consuming. I mean, people at some point we need. I'm not sure how people rely to our early warning system. Just to be honest, but well, just in case we don't have also very much impact data, so it's part that we have to start working with some stakeholders and try to convince them to give us the information. And well, that's also that is with some special users. Well, the people, the common people, as to say. Well, I guess it will be more. It won't be very easy. So we have to work a lot about that. But well, we have to start with at least. We started with some with our stakeholders, and well, it's just part of this. One thing that we have is that we are here in Buenos Aires, and well, we have a very large country just to relate with.
Thank you, Marcos. There are more questions coming up in the chat, but in the interest of time, I would like to move on. Maybe you can answer the questions in the chat by typing. That would be nice. Okay, thank you again, Marcos. Very nice talk. We move on to Thomas Krennert from GeoSphere Austria. Thomas speaks on human weather and impact reports, a crucial support to mitigate extreme weather and climate impacts, ? We see your screen, Thomas. The floor is yours.
Henning, thank you very much. And thank you very much the organizers for making it possible that we can present our program here in a very broad community. So I'm kind of in an easy spot here after the talks, especially from my predecessors, Sally and Tobias and Marcos. I myself am a forecaster, and I am also responsible for this human observation program, which I want to introduce you today. So I can be very quick going through the first slides here because of the talks before. Just a historic overview. we are GeoSphere Austria now since 2023, formerly ZMG ZAMK, Austrian Weather Service, and we started in 2005 with threshold-based warnings, and we started in 2021 with impact-based warnings, and we are still working, as all the other weather services, we are working to further improve our impact-based warnings towards impact warnings, as we also heard it in the talk of Sally here. I just want to show you how we are involved in national crisis and disaster management on various levels. We are involved in the national level, of course, with all the agencies, federal alarm centers. We are not activating any emergency response units. This is done by the federal alarm centers in Austria. As you can see on the right upper side, there is a typical warning page from Austria with impact-based warnings. So the color represent certain impacts, and certain call to action, and a certain call to be aware of the impacts. So we are working closely with the federal alarm centers and with the national and subnational organizations. We are working very closely with the general public, but we have only a few channels to communicate with the public. We do not have access to radio programs or TV or something like that, but we do have direct access to our collaboration with partners or customers, which for them we also provide such warnings. And the very important and gaining aspect here is the European level. So we are involved in the Meteor Alarm project. There is a poster here and at this conference from the Meteor Alarm and EUMETNet project, and also we are involved with the ERCC, the European Commission Rescue Coordination Center, which is acting globally, and we provide expertise together with other European Met services, and thus we are active in the international disaster management as well with our expertise. So this is our involvement in the for our users of our impact-based warnings and our expertise. So a very nice chart I want to show you here. So please follow me. We start at the upper left corner. So as we heard today, especially also from Marcos, as a weather service, we are throwing everything from information, from model information, from remote sensing data and other data sources onto our impact-based weather warnings on the upper right corner, which we still do by hand at most of the time, except some thunderstorm warnings will be distributed automatically on our homepage, but still we are editing our warnings by hand for the most of the warning parameters. And I've already introduced you to our stakeholders, which will receive our warnings, and the stakeholders will likely to tip a response. Here you can see the case which Laura Minetti presented yesterday of Hallein. There was a response of firefighting units, alarm units, which were trying to cope with this extreme weather event and with all the mud and the floods in the city. So the main point is that the data which is available to us in order to forecast hazardous weather is not enough. We do really need alternative additional data, which was also introduced today. And in my talk, I will focus on human weather reports, on eyewitness reports, so to say. And you will follow me to the second loop here. It's the blue loop. So the idea is about that we are issuing warnings, for instance, 2 centimeter hail, and we established a warning system where voluntary weather and impact observers are able to give us real-time feedback loop. Real-time feedback in the sense of a few seconds. So probably we receive a real-time feedback loop of 4 centimeters of hail during a thunderstorm event. And then we are able to modify our warnings for the public and for the people downstream of this thunderstorm, for instance. So this is the basic idea how to do this and how to utilize these human weather reports. How do we do it? We provide a web app which has a low threshold and which is easily accessible. So if you come to the web app, you see more or less a map with the reports from the last 3 hours. And then you might choose to report yourself with main categories here. And the categories are already described in subtitles. So what we call it, it's simply a translation of the handbook of a professional weather and climate observer into easy language, into a language which can be understood by voluntary observers, of course. So you choose one of the main categories, and then you start going through a decision tree. So you decide which parameter and which description is fitting the most to your observed, real-time observed weather impact or weather hazard. And then you can add a photo, of course, or can enter some notes, and then you send this. And after pushing the send button, it will reach your observation will reach us within a few seconds. So this is we already accomplished this. Not to overload our web app, we also provide an outreach platform where we organize events, workshops, and so on. But a little bit later to this, I want to introduce you to the architecture of our concept, of our method. Please also recognize Rainer Kaltenberger and Thomas Spitaler as co-developers of this concept, which is in the original version here, and this concept is still valid after 5 years when we started to develop it. The center point of this concept is the national Austrian weather impact reports database. So this is the center point, and this database is connected with various levels. On the subnational level below, we are connected with our collaboration partners, Skyvon associations, for instance, ham radio operators, but also we are connected to the European level, and we are able to exchange standardized reporting parameters here via application programming interfaces. And this is very nice to have, because if anyone is operating with this API, we can exchange the data, and it's fitting and it's interoperable and it's standardized. So the API is also a major point in this architecture. First, I want to focus on the left side here. This is our outreach work. Why is this so important? As a first step of quality management, we want to make sure that the reports are highly reliable, that we can rely on these reports, and that we are not forced to check whether the report is accurate or not, or to apply any automated checks like probability or plausibility checks, for instance, with the help of nowcasting methods or so on, because we want to verify our nowcasting methods with the reports, with the eyewitness reports and the ground truth which they are reporting to us in real time. So this should be the other way around. So what are we doing? We are trying to train those observers we have a 3-level training program established. So there is reliability levels, 3 reliability levels. There is without training and with basic training, and of course there is the advanced training. And with an advanced training, these observers become trusted spotters. So this trusted spotter program, this training program, is also recognized as a best practice from the European Meteorological Society so far. We are also applying automatic image analysis according to data protection regulations. So we are blurring some people which accidentally are seen in pictures. What you can see on the left side is individual training for a trusted spotter. We are also providing regular workshops with the community here, where there is exchange of expertise and exchange of, for instance, chasing reports or chasing weather chasers. So this is citizen science in the best sense. And of course, trusted spotters will be licensed, and they get a nice license here. So coming back, 1 minute. Thank you. Coming back to this, I would like to focus on the partners. So we are not intruding any communities. We provide with the API that our partners, for instance, Sky1 Austria, is able to report from their own platforms. So this is a very good effect. So we have a lot of reports from trusted spotters. In 2023 already, more than 85% of all reports are coming from trusted spotters. The next thing is, what is real time? I want to focus on this one. So this is a case study from a very small domain here, which we received the first report from a eyewitness observer at a very certain time. And the second one, and the next time step is the station data. And if we are comparing this with emergency response units alerts, we see that it is very difficult to use alternative data here as real-time data, as real-time feedback data, for instance, during a thunderstorm. And the next aspect is Austria is a very small country. It is necessary to have an exchange with the neighboring countries, which we are also trying to establish, especially with Germany and Switzerland so far in the framework of EUMETNet. And as you can see, this is a case where I was on night shift and I had access to the German weather report system. So I was able to make sufficient warning here, for instance, in the area of the town of Salzburg. So this was a short glimpse into our system of human weather and impact reports and how we try to utilize them as an instantaneous and real-time feedback loop in our warning and forecasting activity. So thank you very much. And if you want to have some literature or some more detailed information, please visit our site, our outreach site, trustedspotter.eu in English version. Thank you very much.
Thank you, Thomas. Great talk. There's one question in the chat from Sally. Great talk, Thomas. One of the biggest challenges we have with crowdsourced observations is the ethics of asking people to report what they see when the hazard is still occurring, in case they come to harm. How did you deal with this challenge?
Well, we educate our trusted spotters, and the first rule is personal safety. This is the first rule which we communicate. In case of hazardous situations, personal safety is first thing you recognize, and then after you're in safety, you can report about this hazard, of course. So this is part of our educational and training program.
Thank you. Okay, further questions in the chat for you to ask, and then in the interest of time, we move on with Faye Wyatt. Thank you again, Thomas. And Faye is talking on refining impact data for verification of impact-based forecasts and warnings. Please share your screen.
Thank you very much.
Late. Yeah, go ahead. I see your screen.
Excellent. So thanks for sticking with the time and for giving me an opportunity to talk today. I'm going to be sharing some of the work that we've been doing at the Mett Office, looking at impact data and different sources of impact data and how we might use that for verification of impact-based forecasts and warnings. And this is very much a collaboration across the weather impacts team within the Mett Office and also others within the Mett Office as well. So the first thing that I wanted to talk about was what is impact data? So again, the scene has been set. We've heard a lot about impacts and impact data, but just for completeness, here we define impact data as the systematic collection, reporting, and curation of impacts arising from hydrometeorological hazards. And this is distinct from disaster loss data in that it covers all spatial and magnitude scales, from very, very small events all the way through up to disasters. So impact data then is really important for a range of uses, some of which we've heard tonight, such as refining our thresholds that we might use when we're developing warning systems. It can help us to understand relationships between hazardous events and meteorological events and what impacts you might see on the ground. It can help us to mitigate against or understand the mitigating actions that might be taken in response to the warnings. And importantly, it can provide situational and contextual understanding and awareness as warnings are being issued. But we're going to be talking mainly about the evaluation of warnings today. So there are many different sources of impact observations, as Sally mentioned in her talk. The problem isn't one of data availability, it's about data accessibility and also the quality and the use of those impact observations versus how they were developed and designed. So there are many different types of impact data that we might be able to access, ranging from impact databases through to citizen science and potentially proxies for impact. But all of these have been developed and designed with a specific use in mind that's going to be dependent on the type of impact observation that it is, and also the organization or the source that is collecting and distributing that impact data. So one of the challenges that we have then is to understand what type of impact data should we be using for our application, and what can we do to access that data, and then also to start to use that in earnest. So a lot of this data might be available, it might be provided, but being able to use that within some kind of verification system, it might need to have some level of post-processing. So within the Mett Office, we have been looking at developing an impact database using several different types of impact observations and several different data sources. So we are currently using and obtaining data from 9 different sources now. It says 8, but as of this week, we're pulling in another one. And what we're doing in this diagram is every single day, we are obtaining any new impact observations that we can find from those 9 different data sources. We then compile and standardize that data. And again, this is something that we were speaking about earlier. We heard from our colleagues in Argentina that that's a challenge, and we also found that as a challenge. So what we do is we use a standard data structure that was defined by the IRDR. We make sure that all of our different data sources conform to that, and then we are able to use them within our workflow. As I mentioned, a lot of this data is free text and it's really difficult to work with. So within the Mett Office, we have a natural language processing workflow that will extract and tabulate impacts from free text descriptions. So we apply that in box 3 before then synchronizing all of our data together and pushing it up into our impact database, which runs every single day and updates every single day now. There are 2 other boxes on there which I'll get to, and that is looking at pulling out locations and also defining events. So one of the challenges of using impact data from many different sources is the data harmonization and how you standardize your data across the different sources, but also one of duplication. It might be that each of those 9 data sources are recording impacts for the same event, and you don't want to end up, when you're doing verification, with multiple different records all speaking about the same thing, duplicating information. So the way that we're approaching this then is to define unique events within our data, which might be covered by more than one data source. And the way that we're doing this is by following a methodology proposed by the JRC of the European Commission, whereby you identify a hazard that is common. So if it's a flood, then you look for floods across your database. You look to see if it's occurring at the same time. So is it within the same time window? And then also if it's happening at the same location. And if all those 3 things coincide, then you would consider that to be a unique event. And then you start to aggregate and summarize the impact information that is reported across those different data sources. Obviously, there's a lot of nuance in that, and I won't go into the details for now, but happy to chat afterwards. So we have our impact observations. We have our events defined in our impact data. So the next question is, how can we use that within a verification workflow? So at the Mett Office, we're building on some of the foundational work that was done by Joanne Robbins and Helen Titley in 2018, whereby they developed a framework that basically says, if you want to understand how good your impact-based forecasts and warnings are, you need to look at it from 2 sides. You need to understand, first of all, did the hazard occur? And then second of all, and in combination, you need to understand if any impacts resulted from that hazardous weather. And this hazardous weather and the impacts resulting from hazardous weather is really what we've been focusing on over the last year or so. So just as a quick outline, and I'm not going to go into the details, but we've got a process that we're testing to verify impact-based forecasts and warnings. We're testing 2 different products currently, but we're thinking that this framework might be able to get expanded out. The details aren't important, but highlighted here in blue are all of the places where impact data is absolutely critical. So impact data is foundational to being able to do this kind of verification process. So the way that we're approaching it then, and using impact data specifically, is to understand what the spatial and temporal footprint of our impacts are. So we're thinking about this in terms of a space-time prism. It was a concept that was introduced in the 70s, but I think it works really nicely when you're thinking about impacts. So your impacts will have a location, a spatial footprint represented by that hatched area on the bottom of that figure. Your impacts will have also happened at a specific time, represented by your axes with the time dimension. And what you can do is you can start to plot that then in 3 dimensions to understand what is that envelope of your impacts in both space and time. And we can use that to represent our event. There's a couple of critical things here. Number 1, our impact observations need to be spatial data, and they need to have a timestamp associated with them, or some kind of spatial and temporal control. Once we have that, what we can do is we can look at our envelope or our prism of impacts in space and time versus our envelope or our prism of our warning or forecast in space and time, and look to see how much those 2 overlap. And there's a few different metrics that we can use, but we're looking at the intersection over union, which has been used in computer science, where you're looking at the detection and comparison of different objects. So back to the space. So we need to have that spatial footprint. And I mentioned before that we're looking at geoparsing. So one of the things that we're able to do with all of the different database and data sources that we've got so far is identify locations as place names, text tags, basically, of where that location, where that impact happened. But we have over 50,000 records and growing daily. So we need to have a way of extracting that data automatically. So using geoparsing then, and GeoParsPy in particular, we can identify all of the different place names within our record and then extract out a spatial location. We filter by confidence and also neighboring locations and size, and we end up with spatial data. We can do the same thing looking at all of the dates across our database. And when we do that, we can again build up this date window to give us that space-time prism that we need for evaluation. Some of the challenges, though, is that the geoparsing algorithm, it works really well to detect countries. It does relatively well for large geospatial units. So on the left-hand side here, the admin level 4 is quite well represented by this workflow. But when you move down to the finer scale locations, the geoparsing algorithm, at least at the global scale, breaks down a little bit. So the question for us then has become, can we use ancillary data or alternative data sources to augment these observations so that we can better refine space and time? There's a few different challenges with doing this. Firstly, we need the data to be automatic. We need to have a historical archive. It needs to be global in scope. We need to be able to refine that space and hopefully also make better linkages with the hazard. And we've been looking at a few different data sources to do this. So I won't go into detail, but we've mainly been focusing on satellite imagery because of the global scope, the historical archive, and the automatic processing, but there might be opportunities to look at additional data types too. We've put together a framework of how we might go about and do this, and that consists of 6 steps that I'm not going to go into just for the interest of time. But again, very happy to chat about this offline. But I would be remiss if I didn't mention some of the challenges. So this processing, this refinement, and matching hazard to impacts is not without its challenges. We need to be able to do it better, and that's going to come from increased spatial and temporal control. There is an offset between hazards and impacts, and we need to be able to characterize that and address it more fully. We need to look at harmonization across different types of data, not just satellite observations and impact reports. And ultimately, we need to test this process with a wider range of data sets. But I think that's everything for me. So if anyone has any questions, I'd be happy to take them.
Thank you, Faye. Very well in time. So you can post questions in the chat as usual. There's one from Adrian. Great presentation, Faye. Are there recent publications available on your space-time footprinting system and associated multi-source data use?
No, not yet. So we've got a publication looking at bias and impact data that it came out last year. So we were basically assessing the quality of the different data sources we were using. We have a publication in review currently looking at the process for the automated collection and extraction of impact data, but we don't have anything currently written up about the space-time representation and the evaluation framework, but maybe that's something that we can work on between myself and Joanne Robbins.
Thank you. The degree of automation is really impressive. Next question from Irene. Great presentation, Faye. Quite some work to put together all these sources of impact. So it's actually not a question, but it's a comment. So I see no further questions, but I think you can continue writing questions in the chat, and maybe we can ask, or Faye can answer them later in the chat. So as we are running a little bit late, I suggest that we reconvene at 8:50, which is in 11 minutes, for the next block.
All right, so we'll go ahead and get started again. Welcome back to people that were here prior, and welcome to folks that are joining us for the first time here. Just a brief recap of what we'll be doing. We have a series of 4 speakers. Each of them will have up to 15 minutes for their presentation and questions and answers. If you do have any questions, we ask that you just type them into the chat, please, and that I will take responsibility for reading them out to the presenter. I also wanted to go ahead and send this link again, so you can use this link to drop any questions or comments that are not directed specifically towards the presenter, but more about topics and things that you're interested in into this link here. So I would ask that you would do that. And so we'll go ahead and get started with the first speaker of the second session here. So we have Simon Ageet from the University of Leeds. So the floor is yours.
Thank you so much, Don. So today I'm I want to share with you our project, which is based on satellite nowcasting for Southern Africa. So it's acronym WISA user. So WISA stands for Weather and Climate Information Services for Africa, and then the user stands for Early Warning for Southern Africa. So we have a number of partners who are on the right there, but I won't go through all of them. But they are drawn from academia, national weather services, and social scientists. So with terms of national weather services, we are mainly working with the South African Weather Service, Mozambique Weather Service, and Zambia Weather Service. So these are in Southern Africa. So really today I want to show a small overview of the project and then mainly talk about the test bed. So we have these 2 test beds in the project, and we had the first one over 2 weeks in January, February. So I want to share some insights on what we did there. And then I will also show you some next steps we have planned for the project. So I must say the project is 2 years, and it started in January of 2023, and it's running until June of 2025. So really the vision of this project is to try and increase the access of early warning information to the socially disadvantaged urban groups. And so we aiming to provide, to increase their access to forecasts of 0 to 48 hours. But also we also intend to innovate around nowcasting, because this is proved to be the most critical information for people to take action in a short time. So this kind of images have already been shown and will be shown probably over the course of the week. And you can clearly see that and you already know that the intensity and the frequency of events, hydrometeorological events, is on the increase. And this then increases the appetite of the population for early warning information. In fact, this is the end of the testbed survey we did, and out of 100 people, over 80% of them said the information is useful, very useful, and the remaining ones said the information is possibly useful. So you can clearly see that the information, early warning information, is needed, and we can't emphasize that enough. Now, how does a user work? So how are we working in this project? We're working, of course, like all projects, via work packages. And the first work package is this co-production, evaluation, and economic analysis. So really, if we need people to own into the forecasts we produce, we need to start producing the forecasts with them. So this work package is really to engage with the community from the start through the testbed, and even going forward after the testbed, hopefully. I mean, after the project, hopefully. So that's what work package 1 is working around. And then work package 2 is the one in charge of the products, innovating in the nowcasts. So to produce the real-time weather warnings, and also to develop new products. We are now venturing into machine learning to try and improve the products which we are giving to the community. And then, of course, I think yesterday, one of the keynote speakers said, for early warning for all, the risk pillar, which is pillar 1, is emphasizing working via standard operating procedures. So one of the legacy of the projects, hopefully, is we shall develop standard operating procedures for nowcasting in Southern Africa. And then we have this capacity building work package, where, of course, you have to build capacity. One thing you have to know about Southern Africa, most of the countries are not doing nowcasting, just a few are doing, and even those ones are struggling. So you have to build capacity for the forecasters and the weather service as at large to be able to do nowcasting. So that's what work package 3 is working on. And then work package 4 is the one in charge of co-production through test beds, so conducting the test beds. So we have 2 test beds planned, one which I'm talking about in the next slides, and then the next one which is happening in January 2025. And then lastly, the last work package is the management and evaluation work package, which is looking at the overall management of the project. So going to how our testbed looked like, we had a multi-sited testbed. So I want first you to focus on the top part here. So this is Zambia. As I said, we're working across 3 countries. So the main testbed was this time in Zambia. So we have one forecasting hub here in Zambia, where we have the forecasters, researchers based at the Zambia Met Department. And then we are working with a community which is mainly formed of people with disabilities and underprivileged women, youth. So they are here in the community hub. And then, of course, we have here the end users. So the arrows show the flow of information. So for example, the yellow arrows is the forecast, which we are sending to the community. It can go directly to the end users, but also it can go through the community. And then we have these arrows, the blue small arrows here is the feedback we are receiving. So one thing we also wanted is to have structured feedback, because you can issue a forecast and get any form of feedback, but we intended to get some form of structured feedback. And to do this, we had to engage some community observers. And these community observers would receive the forecast, but also receive a set of questions which they would answer to and give us some sort of structured feedback. And then we replicated this model we had in Zambia in all the other countries. So in South Africa, we had the South Africa Weather Service with some forecasters who are also issuing information to another community in South Africa. This time it's called Katlehong. And then we had another community, another hub in Mozambique. So this is the Mozambique Weather Service, and they are doing the same thing with a community called Boani. So this is how we worked. And so the Zambia testbed was the bigger one this time, but then we had replicated the same in these other 2 countries. And this is how the testbed center at the Zambia Met Service, Met Department looked like. So we had forecasters, of course, producing the different forecasts, and we would have these weather briefings at different times of the day. And on a regular basis, so on a daily, we had different tasks for different types of forecasters. For example, here you can see we had a group on evaluation, we had synoptic forecasters, then we had nowcasters. And here you can see we have 3 groups of nowcasters, so 3 shifts, because we were running a 24-hour nowcasting shift. And during the day, they would have regular briefings. And of course, these are the forecasts we would issue to our nowcasts, but also we would issue a 6-hour outlook of the nowcast, and also synoptic forecast giving the 24 to 48-hour outlook. And of course, these are our reports. And this table extends to the right. We had people for logistics and people to do with IT in the testbed. So going back to forecasting, so the synoptic forecasters would produce a synoptic outlook like this with maps showing, so this is Zambia, is showing places with the different percentages of expected rainfall in the next, or expected weather events in the next 24 to 48 hours. Then the nowcasters would build up on that and come up with risk maps. For example, here you see a 6-hour outlook with the risk, level 2 and level 1 risks in the northern part of Zambia, and level 1 risk here in the southern, this were around Lusaka, the capital city of Zambia. And this is where we had our community we were working with. And then we had the 2-hour outlook, which showed only the northern part of Zambia. And this is a sample of the nowcast issued on the 2nd of February 2024. I'll come back to this case, and we would receive feedback like this from the forecasters. We would receive, of course, message feedback, but we also asked them to give us evidence in form of pictures, and they would send us this. So on this particular day, after issuing the nowcast, it rained. Within the 2-hour, the validity of the 2-hour nowcast, and clearly here you can see that around Lusaka, all this feedback is coming from around Lusaka, which is around this place, it missed this rainfall. And we are looking at that case more critically, but just this is so to confirm what the observers gave us. We also had some automatic weather stations, and you can see clearly here, this blue blob here, some rainfall was recorded. And this rainfall was in the range of 10 to 16 millimeter per hour. But what is clear, what we found out is that most of our nowcasting resources we were basing on mainly the convective rainfall rate, missed the rainfall, and then the rapid developing thunderstorm, something also we use, also was not, some of them picked the rainfall, but the timing was wrong. But because this was a test bed, so we had a lot of products. One product which showed good potential was a product called Rainfall for Africa. This is the it uses the retrieval from Vetosat second generation, but also nudges it with the AI model, and it did a good job. And it actually gave a signal 90 minutes prior to the event, and I will show you this in a minute. So these are some of the nowcasting products we used. On the top here is FASTA, RDT, and CRR. So FASTA stands for Forecasting Africa Storms App. So this is an app also developed here at the University of Leeds, which it's also a product for Africa. And you can see these red parts, these are the RDT, and Lusaka is around here. So during the time of the peak of the rainfall, the RDT was able to show a signal, but then it was not very useful because it all of a sudden appeared, and so there was no forewarning. And the CRR is this blue-green shading, and clearly over Lusaka, which was our region, we didn't see any precipitation. It didn't indicate any precipitation. In the bottom is the nowcasting product from EWSA. And clearly you can see it also has RDT, which is on the corner top right here. You can see these red contours. That is the rapidly developing thunderstorm. But unfortunately, our Lusaka, when she was here, the RDT didn't see any rainfall. So one may wonder if RDT saw it in FASTA, but not in the EWSA product. We put that down to the fact that these products may use different thresholds to indicate a rapidly developing thunderstorm. Now, on the product which gave a signal, this is the Africa Rainfall product. So clearly the timelines are small, but what you can see that from around 11 UTC, there was already a signal. Lusaka is around here, propagating towards Lusaka, and during the peak of the event, which was about 12:30 to 1 UTC, the signal was clearly over Lusaka. If I zoom in into that, you can see that the rainfall did not just all of a sudden come, although most rainfall in Africa is convective, it propagated towards Lusaka. And this product did well to kind of see this almost 90 minutes before. So this leads to a question, because the good thing of it—
Just, you have 1 more minute, Simon, just to let you know.
Okay, thanks. So this product shows that we need to keep innovating and use many more products, and also perhaps go to a solution of using ensemble products. Now, I'll quickly go to the setup of the community hub. We had a community center where people would meet. And so on the left here, these are our community members, of community observers with some of the project team. But here we would regularly meet with the community members at one of the community centers. And just to summarize briefly on what we learned from the community center, in terms of communication, there is no one size fits it all. You need a lot of different communication avenues to be able to pass the message. And of course, we also learned from the community the different, they gave us different things which they think could make the messages easier or better understood. For example, the message should come with an advisory on the impact. And of course, co-production as a mutual learning process is the way to go. So we are taking all the learning from test bed 1 to the next test bed in Maputo next year in January. And of course, we have developed a network which we are hoping to keep on strengthening. Indeed, the Met service is using the network now to disseminate their forecasts. And of course, we are keeping on improving on the products we have. Thank you so much. That's all I had to share.
Okay, thank you very much. So if we have one question that we could answer real quickly, if somebody has something they want to type in, you're welcome to do that. In the meantime, I'm not sure that our next speaker is here. Manabendra Saharia, are you here? Okay, I'm not sure that they're here. So what we'll do, we'll plan on having our other speaker, Elissa Yeates, go ahead and start. So Elissa, if you want to go ahead and share your screen. So thank you, Simon. If you do have questions for Simon, please go ahead and put them into the meeting chat and he can respond to you there. So we'll just go on to our third speaker right now, Elissa Yeates, who is from the U.S. Army Corps of Engineers and also from the University of Georgia.
Okay, hi everybody, evening, afternoon, wherever you are. Don, is my audio coming through okay?
Your audio is fine, but we're not seeing a presenter view yet of the slides.
Okay.
There you go.
There we go.
Perfect.
Okay, great. Sorry, it took me a second to get situated here. Okay, so we're going to shift focus a little bit. Instead of focusing so much on hazards, my presentation is more about a project that's looking at improvement of water management for water supply reliability as a primary driver, although improvement of hazard mitigation is also part of the project. So I'm talking about incorporating principles of environmental justice into forecast-informed reservoir operations in the United States. I'll break down a little bit about what forecast-informed reservoir operations is, and then go into how we are trying to incorporate environmental justice as we expand this program. As Don mentioned, I'm a hydraulic engineer with the Army Corps of Engineers, and then I'm also currently a PhD student at the University of Georgia. But this is a very interdisciplinary team. We work with meteorologists at Scripps Institution of Oceanography at UC San Diego. We've got Don as an anthropologist on our team here at UGA, and then we're also working closely in contact with operators as well. So this is a research to operations program. Just a little bit of background about the forecast-informed reservoir operations program. So reservoir management in general is in the United States for flood control, water storage, hydropower, regulation of environmental flows, recreation at dams and lakes regulated by dams. And as I mentioned, I'm with the Army Corps of Engineers, which has a pretty vast portfolio of about 700 reservoirs across the United States. And our primary interest is in flood risk management. So the reservoirs that the U.S. Army Corps operates are often operated in conjunction with water supply partners or other stakeholders. And there has been a recent change in policy that now allows the Corps of Engineers to use forecasts in our water operations. So in the past, each of these reservoirs is governed by a rule curve, which is historically quite conservative and can only be, release decisions can only be made based on water on the ground already, like precipitation that's already fallen or snow melt in the watershed. So forecasted conditions of these major rain events have not been used officially in making release decisions for flood risk management at these sites. But now that we've had the change to allow forecasted conditions to be used in reservoir release decision-making, we've developed this research and development program to try to figure out the best way to implement this change in guidance. So this figure that I'm showing right now is a graphic from the viability assessment for forecast-informed reservoir operations at our first pilot site, which was at Lake Mendocino on the Russian River watershed in California. And just to, sum up the punchline of the figure here is that the first year that we were able to do a deviation in traditional operations based on forecast information was a relatively dry year. And based on this change in operations, this reservoir was able to go into the end of the water year with about a 19% increase in storage volume compared to what they would have stored in the reservoir if they'd had to operate based on the older, more conservative rule curve, which you can see at the bottom of that lower trapezoid with the water showing the water supply pool. That's where operators would previously have to release to maintain a larger flood space for incoming precipitation. But given the improvements in forecast and the change that's allowing operators to use that information in their decision making, they have more of a variable space that water can be stored in advance of flood events, given that they'll have this warning and time to release water to make room for incoming floodwaters. So the goal of this overall program is to enhance flood risk management, water supply reliability, and support environmental needs by rigorously assessing how forecasts can be used to change the way that each specific reservoir in the core portfolio is operated. Our research question is whether the program can achieve those objectives and then also incorporate environmental justice objectives to support disadvantaged communities and promote environmental justice in these watersheds. So just to be clear on the terminology I'm using here, environmental justice, there's a large theoretical movement and different interpretations of what that term means. Our project is using the term put forth by the Environmental Protection Agency of the United States, that environmental justice is the fair treatment and meaningful involvement of all people, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. So we're thinking here of water management as a policy change that can be creating this benefit of increased water supply reliability, improved flood risk management, and potentially also improved environmental flows. And our aim is to make sure that the benefits to be gained by making this change in reservoirs across the United States is distributed amongst communities that really stand to benefit from that change. So to this point, the pilot sites for the FERO program have been selected based on forecast reliability in the area, and then also having champions or stakeholders at the site who were just very interested in putting in the work to do the full assessment of this change in policy. But we want to make sure as we expand more broadly across the nation that we're considering where those benefits might accrue to communities that have been underserved by water supply operations in the past. And also more broadly than just thinking about those distributional impacts, we want to also make sure that we're incorporating perspectives from these communities in how we assess FERO at these sites. So given the success of FERO at that Lake Mendocino pilot site that I mentioned and several other pilot sites along the West Coast that are shown there by those red stars, there's now a lot of interest within the Corps of Engineers to scale up the benefits of this program and to implement forecast-based operations in as many sites as we're able to safely do so based on the quality and rigor of the current forecast. So to that aim, we're developing a screening process to assess the full portfolio to see where might this change in operations be possible, where would the potential benefit to be gained be worth the level of effort in assessing and changing those rules for operating the reservoirs, and where might we need more research to improve forecast skill to be able to gain those benefits at more sites. So this process is now underway. We've developed a beta test to assess the reservoirs within one division in the southwest of the United States. We've got a kind of tiered approach where we're looking first more broadly at all of the reservoirs within these regional divisions to determine if there are clear-cut reasons why they might not be candidates for this change to use forecasts in operation. And then once we've eliminated reservoirs, we've got a much more in-depth second phase of the screening process where we're working with the water managers at that site to gather quite detailed site-specific information about operations, environmental constraints, relationships with various stakeholders, all of these dimensions that we've identified as being crucial to successful implementation of this program. So our question now in this program or research project that is underway starting this year is how can we incorporate this consideration of environmental justice in that screening? So one way we're doing this is thinking about adding questions to the questionnaire that we're putting forth to the reservoir operators. So they're giving us, as I mentioned, all of this rich information about operational, environmental, collaboration, and other constraints of their sites. So we want to also gather information from those who know the site well about what type of community engagement they have at the reservoir, who benefits from surplus water availability at the reservoir, and how might that distribution of benefits change during wet years versus dry years. We're thinking of how this could look differently in watersheds with a lot of agriculture versus watersheds that have more flooding considerations or water supply reliability, maybe watersheds where there's low levels of water security for clean drinking water, and how those benefits might potentially accrue to disadvantaged communities. And then secondly, we're thinking about what are the vulnerable populations in the watershed. Are there those who could be particularly impacted by a change of operations? One aim of this program is to not impede flood risk management and potentially improve flood risk management, but we are cognizant of the fact that holding more volume of storage in a reservoir could increase flood risk. And so we want to be have a special consideration of how that risk might be distributed before we even consider the level of rigor with which the forecasts can be used. There's also a GIS and mapping component to this work. So in addition to soliciting information from community representatives and stakeholders at the site, we're also using nationally available data to do a higher level screening and identification of where these communities that are water stressed might be. So the data that's being shown in these figures is from the CGES, which is the Climate and Economic Justice Screening Tool, which is developed by the United States federal government within the NOAA agency. And that is a way of using geospatial data primarily from the American Community Survey census data, together with information about climate and environmental stressors to identify communities that are highly vulnerable, high poverty, underserved by infrastructure, and are facing increased risk of climate and environmental stressors. So the way that this 4-year project is structured is in year 1, we are relying on a partner in the Yuba Feather watershed. So this was one of the first FERO pilot sites, the Oroville and New Bullards Bar dams on the Yuba Feather River system. And we selected this site because they do have a high proportion of high poverty community members in the watershed. And the Yuba Water Agency, which was the partner on the FERO project, already has a really strong track record of community engagement. They have a lot of outreach activity, work with the local school districts, do a lot of education and outreach and environmental work in the community. So we wanted to learn from the work of this partner in an existing FERO site and their expertise in community engagement to see if there's a way that our program can replicate that as we start working in other sites. We're also partnered with the Socio-Environmental Education Network, which is a California-based organization that is primarily focused on community engagement and participation in environmental issues. So a real thrust or focus of this project is to improve the way that we're engaging with communities going forward. The assessment of forecast reliability and consideration of how we can change operations at specific reservoirs is highly technical, but it has a large impact and exists in the context of this broader relationship that the community has with the reservoir, with the river system that it's on. And so we want to be very careful in how we're soliciting perspectives from those communities in future projects. So this is a 4-year work effort. We're just starting with year 1 right now. So we're considering those changes that we can be making in the FERO screening process to embed environmental justice considerations.
Elissa, you have 1 more minute.
Oh, okay, thanks, Don. And working with the Yuba Water Agency on that, developing best practices of community engagement. And then in the next years, we'll be screening more sites and reaching out to identify future partners in the South Atlantic Division here in the American Southeast, so potentially in the state of Georgia, to pilot this program in a totally different regional context. So I'll stop there in case there's questions. I can have time to take a couple.
Okay, thanks, Elissa. Yeah, if people have any questions for Elissa, you can go ahead and put them into the box. Okay, all right. Well, you're fine. So we'll go on to our final presenter of this session. And I will say that after the speakers that we have today, we will have a poster session. And Tobias will explain that to us and lead us into that once we're all done here. We'll put up the link and how to get into there. So I'll go ahead and turn it over to Etienne Dunn-Sigouin from the Norwegian Research Center. That's all yours.
Cool. Thanks. So we're going to do maybe come back to hazards here and think a bit more about something different, which is the private sector, which motivated this work. So I'm a senior researcher at NORCE up in Norway. And this work was done in collaboration with some colleagues also at NORCE, Ula and Eric, and as well as the University of Leeds and the Mett Office, so Doug Parker and Richard Keane. So maybe for some context, so I live up here in Norway, and in the summer we were hit by a storm called Hans and caused a lot of damage. And I was told recently that it resulted in the largest mandatory displacement of people in Norway since the Second World War. So this is an image of that, the flooding that resulted from that. And so it was a big deal. And so as part of my project, which is called Climate Futures, we work in collaboration with private companies, but also local governments. But for myself, so these types of events are a really big deal for this insurance company called Tryg. And they're the largest insurance company in the Nordic countries. And so they're really worried about these things, and because it really matters for their customers and their bottom line. And so one of our initiatives amongst many to try to do something about this is to develop a rain damage early warning system. And so our basic idea was to take some rain forecasts, put them inside some sort of statistical impact model and produce an impact forecast for rain damage to homes. And through that, we would develop an early warning system, possibly through sending SMS. Still working on that bit. But the point is that I'm pretty interested in the forecasting part. And before people tune out immediately, because there's a very diverse audience here, I think it's a very important thing to sort of think about how to use this data inside this sort of impact forecasting world. And so I thought a little about that, and I read some papers, especially in the social science and sort of climate services world. And it got me thinking about sort of two topics. So the usability gap for sort of weather and climate information, and this concept of maladaptation. And so we know, because of events like I showed before, that society needs sort of accurate, precise, and timely predictions. But we need to do something with them, right? And often forecasts are sort of just not precise enough. And so here I have a map of a very coarse map of Bergen overlaid on sort of a typical forecast grid. And so the point is that sort of the city of Bergen is essentially maybe like this grid square here. And so it really doesn't capture sort of at the resolution that people really need. And so this leads to this idea of this usability gap that for many reasons, but for this specific one I'm mentioning here, that forecasts are just not precise enough to be useful. And that's an issue for the uptake and the use of forecasting data. But there's also sort of the flip side, which is this sort of maladaptation side. So forecasts can actually be more precise than they are accurate. And so what I mean is that sort of they're more accurate on larger scales. So if you average over these 9 grid boxes as opposed to just looking at one, so the 9 grid boxes together might be more accurate than the individual ones. And so if you, as a user, if you don't know sort of these characteristics of forecasts, then you might use this type of data in the wrong way and potentially lead to maladaptation. And so my claim here is that sort of users need a simple method of evaluating the trade-off between spatial forecast accuracy and precision. And so I thought about, okay, so how can I develop a way to sort of help my colleagues at this insurance company sort of understand this data and then even further build on their sort of their early warning system. And so I came upon this concept from, or this score from previous work, so specifically Roberts and Lean. And so the idea is basically that if you average on across more grid boxes, you might have a more accurate forecast. So here, say you have observations as a function of X and Y. The gray grid boxes, say, are where it rained, and then white grid boxes are where it didn't rain. And then you have your forecasts on the same grid. And so the gray boxes don't match exactly. And so on an individual grid scale, so the smallest box, let's say the one in the middle, you might have a bad forecast. So it rained in the observations, but not in the forecast. But if you just take a bigger box over these sort of 5 by 5 grid boxes here, then you have the same amount of rainy grid boxes. And so you have a good forecast. And so the idea is just decreasing the precision might increase the accuracy. And depending on what user you are, this might be a useful thing to know. And so I decided to put my spin on it and sort of extend this a bit. And so no worries if some people here are not the sort of expert forecasters, but the basic idea is I'm applying a smoothing and then I'm looking at accuracy. So I take some ensemble forecasts, so many ensemble members that come out of a forecasting model these days, which could be AI maybe. But anyways, so then I smooth them at different scales. And then I create these plots of sort of precision versus lead time and where the colors are accuracy. And here I'm specifically looking at extremes of precipitation. And so for those who know this forecasting business, this is a sort of fractional Breyer skill score. And so in order to sort of to test this idea, so I'm using forecasts from ECMWF, and so I'm using a large database of forecasts. So 3 years, which is something like 300 forecasts, and I'm verifying all my forecasts relative to some truth, which is a reanalysis product. And so this is sort of the main result. So I make these plots, which have on the y-axis, which is lead time in days, and actually the x-axis, and on the y-axis is precision in terms of grid points squared. So these are different boxes of different sizes that I'm averaging the data over. And then on the other y-axis, I've sort of roughly converted that to kilometers squared to give a sort of physical size. And the color shows the accuracy. So if it's bluer, it means it's more accurate. And if it's wider, it's not accurate. And it's accurate or not accurate relative to a climatological forecast. So this is sort of our basic, dumbest forecast that we could do to compare. And so the key point here is that these lines of accuracy change as a function of precision, which is sort of what we were getting at before. And so documenting this and showing this to my colleagues is actually quite helpful to get them to understand how to use this data. But an interesting thing that it's essentially the same statement, but formulated in a different way. So this is the same plot. Again, lead time on the x-axis, precision on the y-axis. The contours in gray are this accuracy measure. So they get more accurate in the top left-hand corner. But overlaid is a rough calculation of the lead time one would gain by looking at your forecast at a higher spatial scale. So just to give you an example, so say I'm interested in a forecast at an accuracy of 0.4, and I start, and I have a precision of roughly 33 grid points squared. And so if I go down this line of constant skill and I compare it to the grid scale, so the difference in lead time for the same accuracy is on the order of a few days. So what this means is that you can actually gain lead time, so gain predictive skill, but just by going a bit higher in spatial scale, which might be useful depending on what type of user you are. So you actually gain sort of the future becomes a little bit clearer if you actually become a little bit coarser in spatial scale. And so, and just to sort of round this out, so you could do this, these calculations I did was over all of Europe, but you can do that individually over sort of grid points across Europe. And so the basic idea is that for these extremes is that at high precision, so at a grid scale, you have a certain amount of accuracy. This is for just a snapshot and lead day 5. But when you go to lower precision, the colors become a little bit darker, a bit overall, and they become a bit bluer. And so this is like, so essentially it applies on the grid point scale, so roughly. So maybe that was a bit technical, but I think thinking this way and showing this to my colleagues was actually quite an interesting thing to do. And one of the reasons that has important applications or implications rather. And so one of them is that, so this sort of begs the question that we could communicate forecasts at the skillful scale, not at the default grid scale. And so here's an example for a storm Hans. So this is the actual forecast from ECMWF. And so we have sort of the what happens on the bottom right. So there was a lot of rain over sort of some parts of Sweden and over Oslo specifically. This is where this flooding image was taken down there. And so on the plots on the top and onto the left, what you see is a sort of my image of what that would be, this communication at skillful scale. So you pick a scale, but you know that further out in time, the coarser sort of your forecast can be. So the idea is that 3-day lead time, it has sort of a spatial scale sort of roughly represented by this grid, this red box. And as you go forward in time towards what actually happens, you reduce the grid box, basically the smoothing. And so things become gradually finer and finer, right? And so, but the idea here is that you're showing, you're communicating this forecast at the scale in which there is skill. But if you show it at the grid scale far off in time, then you're actually showing a forecast that's more precise than it is skillful. Yeah. So, and there's the last sort of application or implication is that we could design better impact models. And so here I said, I mentioned that I'm collaborating with the private sector. And so they were interested in building a statistical model that would make a prediction for housing claims. But by thinking about this sort of accuracy versus precision trade-off, what you think about is that, so the grid scale might not actually be the right scale for these input forecasts that you put into your model, right? So you might actually have to modify your input in order to get a better impact forecast. Or depending on this trade-off, you might actually have to modify your model. And so this was very applied to insurance, but I think it has sort of very important implications across all impact forecasting, essentially. Especially when it comes down to this sort of statistical modeling of sort of impacts that are functions of weather and climate, but they're not directly modeled by them. And so one needs some sort of mathematical framework to use them, and you need forecast as input. So just to conclude, so essentially we developed a method that helps users evaluate this trade-off between forecast accuracy and precision. And so I showed that decreasing precision can extend predictable lead times. But one thing I forgot to mention actually is that it can actually enhance the maximum accuracy possible. So that's interesting as well. And it has important implications, which is communicating forecasts at the skillful scale, not at the default grid scale, for more actual information, or it could help us design sort of better impact models in these early warning systems. So, yep, thanks.
Okay, great. Thank you, Etienne. I appreciate that. So we have about 2 minutes if anybody wants to type in any questions for Etienne. So we have a question from Beth that says, nice talk, Etienne. A danger of averaging within spatial neighborhoods to improve mean accuracies that extremes are washed out. Could you adapt your time-varying neighborhood approach to probabilistic space?
Yeah, so maybe it didn't come across, but so this Brier skill score is a probabilistic measure of skill, and so so there is some so there is probabilistic information there. So I guess the claim here is that on the grid scale, you might not be able to represent that that extreme anyways. And so what you can represent and what you can communicate is actually an extreme on a bigger box. So yes, you're washing it out, and implicitly it's not the same event, but on this bigger smoothing, but it is what you can skillfully communicate or predict. And so that's the best you got. So I'm just showing people that there's this trade-off there about what you can actually predict and what you can't. So you can go ahead and use whatever grid scale or spatial scale or precision that you want, but this is just showing that there's this trade-off, and that is useful depending on what type of user you are.
Okay, great. Thank you, Etienne. I appreciate it. And thank you to all the presenters, all three of you that we had for this block of presenters. I'm going to go ahead and turn it over to Tobias now to lead the lightning talks.
Yeah, thanks, Don, and thanks for all the contributions so far. Very exciting session in my view. And thanks for sticking with us. We will have we had a lot of contributions asking for oral presentations. We really appreciate your submissions, but we had to also delegate some of the presentations to the poster session. And in order to give the people, presenters, a chance to attract attention and say a few words about their posters to be presented in GatherTown, we would now take around 15 minutes to for the poster presenters to give a 1-minute short presentation of their posters. We didn't receive poster lightning presentations from all poster presenters, so we have 11 people submitted presentations. I will share my screen now, and then I will just ask the people in the order of appearance to just unmute themselves, say a few words, 1 minute max, and after that we will then meet in GatherTown. I will put the link of GatherTown into the chat box now. So once we're done, you're invited to join us in GatherTown, choose your avatar, walk around, chat with people, hang out with us, and yeah, it's a nice experience even just walking around with your avatar in GatherTown if you haven't done so. Okay, let me just share my screen and see. So the first person to to talk about his poster would be Abu Bakr. Are you here? Can you say a few sentences about your poster to be presented? So I guess you're not here. So then I will go to the next poster, which is by Irene Garcia-Marti. It's on piercing through the spatial scales. How finely can we predict wind damage to urban trees? Are you here?
Yes.
Can you say a few words?
I'm here. Can you hear me?
Yes.
Okay, great. Yes, so good evening, everyone. My name is Irene, and I work as a data scientist at the Dutch Mett Office. And in this minute, I would like to persuade you to come and talk with me to the poster room about this exciting project that we carried out last year at the KNMI in collaboration with 2 safety regions and 1 commercial company. So basically, a safety region is a small area in the Netherlands in which there is an office that coordinates the police, the fire brigades, and the emergency services. So we got data from them. We basically got 5,000 locations where damage due to windstorms happen, and we basically apply a process of combining these observations with hazard metrics and exposure metrics. You can see the stack there, and we model this big table of data with machine learning methods just to come up with some maps depicting the suitability for a particular region to receive wind damage, and we apply this for this big storm that swept Europe 2 years ago in different scenarios, including different types of spatial information. So yeah, I would be very happy of discussing about these topics with you all and possibly getting your feedback and expertise for the future. Thank you.
Thank you very much, Irene. Very interesting work. Looking forward to see you in Gathertown later.
Thank you.
The next person would be Aldana Aruti on advancing early warning system for urban flooding and nowcasting approach with radar data and ensemble techniques in the Prevenir project. Are you here to say a few words?
Yes, I'm here. Can you hear me?
Yes.
Well, my name is Aldana Ruti. I work at the National Meteorological Service of Argentina. This work is in the framework of the Prevenir project, that is a 5-year international cooperation project between Argentina and Japan. And the main objective of this project is to develop an early warning system for heavy rains and urban floods in 2 regions of Argentina, in 2 basins, one located in the Buenos Aires province and one in Córdoba province. One important development in this early warning system is to develop a precipitation nowcasting system that it will act as an input of an hydrological model. So the idea is to talk about these advances in this precipitation nowcasting system. Thank you very much.
Thank you very much, Aldana. Looking forward to see you in Gathertown.
Thanks.
The next presentation would be by Maria Paula, and I'm lost here for the last name, sorry. Would be on gauge adjusted satellite precipitation product for Argentina and the Prevenir project. Are you here to say a few words?
Yes, I'm here. Can you hear me well?
Yes, we can hear you. Please go ahead.
Great. Good evening and nice to meet you all. This work was part of a research stay last year as part of the same project that mentioned Aldana. I'm a researcher from the National Meteorological Service in Argentina. And the motivation of this work is the interest in improving precipitation products. And the objective of the work is progress on the optimal combination of the satellite estimation from Japan with the rain gauge data at the National Meteorological Service. So good to discuss the data, methodology steps, and preliminary results in the platform. Thank you.
Thank you very much, Maria. Looking forward to seeing Gathertown in a minute. The next contribution would be by M. Lagers on probabilistic hydrological forecasts forced with short-range numerical weather prediction ensembles, also from the Prevenir project. Are you here to say a few words?
Yes, here I am. Can you hear me well?
Yes, we can hear you. Please go ahead.
Okay. Well, this work was carried out in the framework of Prevenir Project 2. It's focused on the same 2 basins. We developed 2 high-resolution data simulation independent systems with work on scale numerical weather prediction models for both basins, obtaining 20-member 6-hour ensemble forecasts. Hydrological models were forced with this ensemble forecasted precipitation to get an ensemble of hydrograph of flow, discharge, and water level. And lastly, well, this probabilistic hydrological forecasts represent a potential improvement for the nowadays available tools for decision makers and civil protection services. Thank you very much.
Thank you very much for your few words here, and see you in Gazatown in a minute. The next contribution is by Javier Singh. It's on enhancing heatwave prediction in India, on machine learning, bias correction, and societal response strategies. Are you here to say a few words? He or she is not here, so let's move on to the next presentation. The next presentation will be by Sakshi Sharma. It's on bias correction of maximum temperature forecasts from ensemble models using various machine learning techniques for Ahmedabad station. Are you here to say a few words? It's probably a very bad timing for India. We have a presentation by Rodrigo Ribeiro, the unprecedented heatwave event over the city of Sao Paulo in Brazil during 2023. Are you here to say a few words?
Yes. Thanks, Tobias and everyone present here. The objective of my name is Rodrigo. I work in Sao Paulo, Brazil, with climate data analysis and impact post-disasters context. So this work that I'm presenting here today, it was an analysis of the heat waves during 2013, having the city of Sao Paulo as the case study. Basically, I used two methods to identify the heat waves during 2007 and last year, 2033. I used one station, the station of biggest historical data, and we have two results. One identifying 30 heat waves, and the other that is more restrictive, 15 heat waves. But I think the main conclusion of this study is that both converge to the conclusion that of how strong it was the heat waves. It was the heat wave of last year, 2013, and how they are increasing the occurrence. Also, the motivation was the last year was the highest temperature in Brazil as well. Thanks very much.
Thank you for presenting here, and looking forward to see you in Gathertown in a minute. Let's move on. The next presentation would be by Ayok Pasca, El Niño performance and impacts on Uganda's Great Lakes for sound season. Are you here to say a few words?
Yes, good morning, everyone. My name is Ajok Pasca. I work with Ministry of Water and Environment, Uganda. And in this study, we're trying to understand the performance of El Nino forecast onto Uganda Great Lakes. And most importantly, to understand the response of the community to the forecast and the predictions, and how well they prepared for the forecast, how well they responded to the forecast, and which major basins was affected the most, and what initiative was taken by the government in order to alleviate the impact of the El Nino. Yeah, I think we'll talk more in the gather. Thank you.
I don't know if there's still one left. I think, yeah. So there's another contribution by Chukwinder Kaur, optimizing NCM RWF model predictions for extreme rainfall events through parametric bias correction methods. Are you here to say a few words on your poster? Yeah, there's another one by KKG Pereira on machine learning for impact-based flood forecasting in Sri Lanka, a case study of Kilania riverine flood impacts on buildings in Kaduela. Are you here to say a few words? No, I think that was all the contributions. So thanks for sticking with us, and thanks for the presentations, not only the poster presentations, but all the oral presentations we had so far, and the discussions we had. please find again the link in the chat box and how to proceed to GatherTown, and we will close this session here. And on behalf of all the conveners, Henning and Dunn, we thank you very much for your contributions, and see you in a minute over in GatherTown.